Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will study about the stream function. As you know that in previous video we had discussed about the velocity potential function. So in this video we will discuss about the stream function. So what is the stream function? It is defined as the scalar function of space and time such that its partial derivative with respect to any direction gives the velocity component at right angle to that direction, and it is usually defined in only two directions. Okay, so what is the stream function? So stream function psi is equal to is function of x, y and time. Okay, now if we take derivative of the stream function with respect to x, then it will give velocity in y direction. And what is the velocity in y direction? See, velocity is given as, in two direction if we write, ui plus vj. Okay, so in y direction this is x, in x direction this is in y direction. So what will be the velocity in y direction? V. Okay, so this is written here. Similarly, del psi upon del y is equal to, it will give direction perpendicular to the y direction. So what is direction perpendicular to the y, which is x, and velocity in x direction is u, so it will give velocity u, and remember that it will be minus here. Okay, so this is the essentiality of stream function. Okay, now what is our continuity equation? We will check it with a stream function with continuity equation. So what is continuity equation? It is del rho upon del t for 3D, del rho upon del t plus del rho u upon del x plus del rho v upon del y plus del rho w upon del z is equal to 0. So if we consider incompressible flow, then del rho upon del t will become 0. Del rho upon del t which means change of density with respect to time. Then if fluid is incompressible, then density will never change, okay, with respect to time, so it is 0. And if here it is rho is considered variable because it is inside the differential. Okay, so if it is steady flow, then this is for incompressible flow. If it is a steady flow, then density will not change with x, y and z. Okay, so density will become constant, so it will come outside of the bracket, so it will become rho will be common in all these three, del u upon del x plus del v upon del y plus del w upon del z is equal to 0. So this will become 0 or this will become 0. So rho is density is not 0, so it will become del u upon del x plus del v upon del y plus del w upon del z is equal to 0. This is stream function, sorry, this is continuity equation in 3-dimensional for steady flow and incompressible flow. If we talk about two direction, then third component will be 0, so it will become del u upon del x plus del v upon del y is equal to 0. Okay, now if you put the values of u and v here, so what is u? See, u is minus del psi upon del y. If we write del u upon del x, del u upon del x will be equal to minus del square psi, or you can write it del upon del x minus del psi upon del y, so it will become minus del square psi upon del x del y. Similarly, del v upon del y is equal to del upon del y del psi upon del x, so it will become del square psi upon del x del y. Okay, so if we put these values here in continuity equation, then del u upon del x is minus del square psi upon del x del y plus del v upon del y is del square psi upon del x del y, which is equal to 0. So this is our continuity equation in form of a stream function. Okay, so if a stream function is satisfying the continuity equation, so if a stream function exists, then it denotes case of, means it represents case of possible fluid flow. Okay, so we have to check if this fluid flow will be rotational or irrotational. So if fluid flow is irrotational, then Wz will be equal to 0, and Wz is rotational component in z direction, which is given as half del v upon del x minus del u upon del y. So del v upon del x we have already calculated, sorry, del v upon del x we have not calculated. So u is given as, see here, or we can, u is del psi upon del x, so del psi upon del y, and v is del psi upon del x. So from here we can write that del v upon del x is equal to del upon del x del psi upon del x, which will be equal to del square psi upon del x square. Similarly, del u upon del y, this del u upon del y is del upon del y, u is minus del psi upon del y, so it will become minus del square psi upon del y square. Okay, so if we put these two values in this equation, then omega z is equal to half del v upon del x is del square psi upon del x square minus, this is also minus, del square psi upon del y square is equal to 0 for rotational flow. Okay, so this will become del square psi upon del x square plus del square psi upon del y square is equal to 0. So if this stream function is satisfying the Laplace equation, then it is a irrotational flow. Okay, we will use this property in upcoming numerical problem. So I hope you understood this problem. If you have any doubt, then you can ask in the comment section. Thank you for watching.